are looking at the next section of your solutions unit. And as we look at the next section of your solutions unit, we're going to look at dissolving things, dissolving your solute into your solvent specifically. And as we look at dissolving, there's only so much room that we can add the solute to the solvent. So we're going to look at three different distinctions of a solution and how much solute you have in that solvent overall. Eventually we're going to mathematically calculate this, but for right now we're just going to look at unsaturated, saturated, and something called supersaturated. And I'm going to show you what each of those actually look like. So when you're adding sugar to tea or salt to water or Kool-Aid powder to the water or whatever you're trying to dissolve in, there's only so many little places that your solute can actually fit into your solvent when it evenly distributes. Once it runs out of room, you make a different type of solution. So we're going to look at these different types of solutions, specifically starting with the unsaturated solution. And then after we look at the unsaturated solution, we're then going to look at the saturated solutions once we have no more room. I don't know why I got so big, sorry. There we go. So when you're adding your sugar to your water or your salt to your water, whatever you're trying to make, there is still more room. So you add like a little bit of sugar in there, you mix it up, it all dissolves away. Add a little bit more, you mix it up, it all dissolves away. That means that there's still more room for that sugar to dissolve. That is called an unsaturated solution. So I kind of compare it to my classroom. And when I look at my classroom, if I have 30 desks in my room right now, and with those 30 desks that I have in my room right now, if I only have 2 students sitting in desks, I still have more room for students. My room is unsaturated. Let's say that I have 5 more come in, so now I have 7 students. With those 7 students, I still have room for students to sit down, so that is considered to be an unsaturated situation. I still have more room. If I have 29 students, I still have 1 more desk. So because I still have room for those students to sit, I'm still unsaturated. Once that last student sits down, and I have 30 kids in 30 desks. I'm trying to get my picture back up, sorry. There we go. Once I have all of my students in desks, so let's say I have 30 desks, I have 30 kids sitting in those desks, I am out of room. When I am out of room, that's called a saturated solution. So with my sugar in my water, I add a little bit of sugar, I dissolve it, it mixes. I add a little bit more, it dissolves, it mixes. I really don't know if I'm out of room or not until it hits a point that you have extra sugar crystals just kind of hanging out in the bottom. So let's go back to my desks. Let's say that I have to collapse 2 classrooms together. And if I have 2 classrooms together, the other teacher comes in, they said, oh, can you watch my kids for a few minutes? I said, sure, go ahead and sit down. So I have my students in here, the extra students come in, they sit down. I have 36 kids in the room. I only have 30 desks. So that means that I have 6 extra kids that don't have a place to sit. So if I don't have a place for those kids to sit, they're just going to stand or hang out or sit on the floor. The sugar does the same thing in water. So you add the water, or add the sugar to the water, add the sugar to the water, add the sugar to water. Eventually you're going to have extra sugar crystals just kind of hanging out in the bottom. That is still a saturated solution.
Let's go get all second round students directly
so
to the bus ramp.
with
Second round
my
directly to the bus
saturated
ramp.
versus
Students do not have
unsaturated
tutorials today.
solutions,
Please go home. Second round directly to the
sorry,
bus ramp.
here's an announcement.
Get done.
With your saturated or unsaturated solution, you don't really know which one you have because they look identical, except when it's truly saturated, you might have extra crystals hanging out in the bottom waiting to dissolve in. So let's say that we increase the temperature, particles start moving faster, there's going to be more room because things expand when they get hot. Or let's say we add more water, particles start moving, they actually go into the solution. But the unsaturated versus saturated, we're not really sure which one is which until we hit that saturation point. Now, this other category of solution is called a supersaturated solution. So I always use the Harry Potter example for this one. And I say, okay, in my classroom, we have a normal desk, but I'm going to increase the temperature in my room. And when I increase the temperature in my room, my desks are magic. And when it gets warmer in the room, the desk turns into a little love seat. So the love seat's the little couch that has 2 cushions on it. So now each student can have 2 people sitting on each desk, and both of them are very comfortable. Same thing happens in a solution. You take that solution, the particles start moving faster and faster and faster. When things move faster, they expand. So the little seats that you have available for the solute to sit down, there's more of them. So more sugar can dissolve in. Same thing with my desks in the room. I increase the temperature in the room. The desk turns into a love seat. 2 people sit down. They're very comfortable. They're sitting there. It's no big deal. But then it cools back down. As it cools back down, it happens very slowly. So the desk gets smaller and smaller and smaller and smaller. So you don't really know what it's happening, but if you have 2 people sitting on the left seat and it's slowly getting smaller and smaller and smaller, you're like, wait a minute. This person's getting closer to me. Oh, they're really close to me now. Until eventually, like each person, like one is sitting on the other's lap. So you're very uncomfortable. And what we say with that is the fact that you have these 2 little particles in the one seat and they're unstable. So it doesn't mean that they're going to explode. What it actually means is when you have those 2 little people or 2 little particles in that one spot because it heated up, everybody sat down comfortably, and then it cooled and got smaller, what's going to happen here with it being unstable is the one particle, the first chance that it gets, it's going to kick that other one out. So when it becomes unstable, what's going to happen is it's going to have a disturbance of some sort. A lot of times it's just moving it or maybe adding one more crystal to set it over the edge, or maybe a piece of dust hits the top of it or something like that. When you have that disturbance that happens, the extra crystals, because there's too many of them, they're going to crystallize out. So part of them stays in the solution, but the extra stuff goes out of the solution and it crystallizes. So I've got 2 videos that I'm going to show you what's actually happening with a supersaturated solution. These supersaturated solutions, it's called sodium acetate. I found these videos online. It's another teacher doing them because I couldn't get a good enough video of the sodium acetate actually crystallizing. And this one is really good. So this is the one that it is a teacher. He's teaching his class. He made a supersaturated solution, and he's going to show you what happens when it crystallizes out.
Zoom in, Rena. I don't know how. Go closer. Hold on.
Just start.
You can't even see it. Okay, go. Okay, well, there's a crystal. You might crystallize your. It's not gonna crystallize on me. On your phone.
Ready?
Yes.
So realize this has been sitting there all year long like this. Okay.
What is it?
I'm
What
gonna
is
change. Huh? Well, it's water that has a huge amount of these crystals dissolved in it.
Oh.
It has so much of it that is called supersaturated. It actually is holding more salt than water actually can. How does that work? Because I boiled it.
You dropped it in there?
Oh! What?
Oh snap! Oh my gosh, that's so cool!
It looks
So
like
pretty.
a
It looks like a puffball. My finger ran out of it. Oh my god. Oh my god.
That's so cool.
What happened to the bug? What happens if it's still over there?
That's so
Ow. Cool. That was just one drop. It's right there.
One crystal.
Imagine.
Look at it extending from the
So
bottom.
pretty.
Oh, that one's racing. It's racing. Look, that one's Jeremy. He got it.
Yeah, I get there first.
Watch it. I see my nail. I want my nail to be in the picture. Oh my gosh. This is giving me goosebumps. It does look kind of weird. This is so cool. Is this real? They look like feathers. Can we touch it? Are we gonna
No,
blow it?
wait till it's all crystallized.
You would touch it either way, but
I
I touch
would.
radioactive things. Oh my gosh, poor Austin. You can't see like that. Rena, stop. He's having more fun. Are you gonna break it off and give pieces to all of us? Can we both? Have you touched it?
Okay, I'm actually going to stop the video right there. If you want to watch the rest of it, again, it was just a student that was recording the class for the teacher. And when he added that one extra crystal, it caused enough of a disturbance that because you had too many particles that were there, it kicked the extra particles out. And so you actually still have solution here. It just kind of gets trapped inside of those crystals. So if you picked it up, you would have liquid that pours out. So it's not totally solid, but this is extremely exothermic as well. So they actually use this to make hot hands or hand warmers. And you might have seen these in like an athletic store or something like that. It's a clear liquid, and you hit a little clear or a metal disc inside of it, and it actually crystallizes out like this, super saturated, and it heats up for a very long time. And then you can put it back into boiling water. Those crystals go back into the solution, and then you can recrystallize it again. So they're reusable hand warmers. And they used to be very popular. I'm not quite sure if they are still as popular or not. But the solution itself, if it breaks open, it kind of smells like vinegar because it's sodium acetate. Now this other video, they kind of do the same thing where they take a supersaturated solution, but he's going to pour it out instead. And when he pours it out, you're going to make like a column instead of in a beaker. So again, I'm going to show you this one as well. So there's the crystal. Okay, and then this goes on for another like minute and a half, so I'm gonna stop there. Again, if you want to watch the whole thing, you can definitely watch the whole thing. It is in the notes, and you just click play and it'll play all the way for you. So the difference here, unsaturated means that there's more room for solute to dissolve. Saturated means that you are out of room. Super saturated means that you take a saturated solution, you heat it up, you put more particles inside of the solution than what should actually fit, and then after that, you cool it back down. So you have to go through that whole process. Heat it, add more, cool it, and then it's called a supersaturated solution. Supersaturated solutions are very unstable, which means that they'll kick out the extra particles the first chance that it gets. Now, in today's notes, we have just a little bit more to talk about. Again, just a little bit of vocabulary. The next little topic that we have is has to do with dissolving. So the end of the dissolving parts that we're talking about is the fact that two things don't always dissolve into one another. So with your rule to figure out if something's going to dissolve into the other one or not, it's called the like dissolves like rule. Like dissolves like just means that if you have something that is polar, it's soluble in a polar compound. Polar dissolves polar. If you have something that is nonpolar, same thing, it will dissolve into something that is nonpolar. So like dissolves like. Polar dissolves polar, nonpolar dissolves nonpolar. If you have something that is polar and something that is nonpolar, they don't mix together. So they have different polarities, they're not going to mix. So I've got a bottle here. I have blue food coloring in water, and I have baby oil. The blue food coloring dissolves into water because it has the same polarity. So those two are mixed together. But the water and the baby oil do not mix together. Reason why they don't mix together is because they have different polarities. Water's polar, we know that. That means that your oil is nonpolar, they don't mix. So if I turn it on its side like this, the two things do not mix together and it makes a little wave pool. If I shake it, it is still not going to mix together. So no matter what, the two things are not going to mix because of the like dissolves like rule. You have to have the same polarities in order for them to dissolve. So if something is polar or ionic, they will dissolve into polar or ionic substances. Nonpolar will only dissolve into nonpolar. So like dissolves like. And the last thing that we're going to talk about is effervescence. When you have gas particles that are rapidly escaping from a liquid, that is called effervescence. If you think about, this is Alka-Seltzer. Alka-Seltzer effervesces. In a liquid, makes bubbles. Soda. When it's in the bottle, like if this was a soda, when it's in the bottle, the gas is all dissolved all throughout the soda itself, and then there's a little layer of the gas at the top. When you open the soda, that pushes the gas into the liquid, and then it effervesces back out. So that's why a soda eventually goes flat, is because that gas that's trapped inside of the liquid all effervesces out. So it's just a word that you hear kind of frequently, and I just want to make sure that you know what that means. So that is, I believe, the last of your notes for today. If you guys have any questions, ask. Otherwise, have a great day.